At breakneck speed, this mysterious object is zipping through our galaxy. It's moving at a staggering 1 million miles per hour. That's so fast it might potentially escape the Milky Way altogether. While scientists are trying to understand exactly what this space weirdo is, we're going into space to learn more about it. The object is currently moving at a distance of 400 light-years away from Earth. Let's have a closer look and try to figure out if it could be a runaway probe. Nah, it's way too large for that. The object is around 30,000 times the mass of Earth and 8% of the mass of the Sun. What a giant! Such a size places it in a category that Dr. Darren Baskill, an astronomy lecturer at the University of Sussex, describes as somewhere between a star and a planet. Stars moving at such extreme speeds are super rare. Only 1 or 2 out of every 1,000 local stars travel so incredibly fast. So, if one day you found a star moving as rapidly as our cosmic enigma, you'd see it leave our home Milky Way galaxy in just a few tens of millions of years. In terms of space and cosmic distances, it's a blink of an eye period of time. After all, such stars can live for tens of billions of years. Even though the mysterious object is only moving at 0.001% of the speed of light, it's still potentially fast enough to eventually break free from the gravitational pull of our galaxy and fly into intergalactic space. Let's put this speed into perspective. J1249 is traveling 2.6 times faster than the fastest space probe ever launched. I'm talking about the Parker Solar Probe. The Parker probe reached this speed in June 2024 while looping around the Sun. J1249 was discovered by citizen scientists volunteering for NASA's Backyard Worlds Planet 9 project. These volunteers sift through online images taken by NASA's Wide Field Infrared Explorer and NEOWISE missions. They're looking for anything interesting. 3 of those volunteers spotted a faint, fast-moving object as it moved across WISE images. When they realized what they were looking at, they were incredibly excited, but thought someone had already reported the space object. But surprisingly, that wasn't the case. At the moment, most scientists believe that CWISE J1249 could either be a low-mass star or a brown dwarf. That's a type of star that is larger than a planet but too small to support nuclear fusion in its core, like our Sun does. In other words, such stars don't have enough mass, and their cores can't burn their star fuel, radiating starlight. That's why brown dwarfs, often referred to as failed stars, are smaller and cooler than the Sun. They even have complex planet-like atmospheres, which have clouds and molecules. For example, H2O. Anyway, to confirm or disprove this theory, astronomers continued to observe the object with the help of ground-based telescopes. Soon, they found out that the object had an unusual composition, with much less iron and other metals, compared to typical stars or brown dwarfs. It allowed NASA to claim the unthinkable. J1249 could be one of the oldest stars ever found in our galaxy. Okay, that's certainly a game changer, but why is this potential star moving so fast? The research team has a few theories. For example, the object might be the remains of a binary star system where its companion, a white dwarf, exploded in a supernova after pulling too much material from J1249. Another possibility is that our mysterious traveler may have originated from a cluster of stars that dispersed after coming across 2 black holes. According to experts, one way to get to such extreme speeds is to fall toward an object and miss it. Such gravitational slingshots are how space probes are accelerated to extreme speeds, which allows us to explore the solar system up close over reasonable timescales. The same technique could also explain the speed of J1249. The star could have been born in the crowded center of our galaxy. Then it might have fallen toward a star, missed, and in the process was accelerated to extreme speeds. Well, let's leave astronomers to search for more evidence to confirm this exciting theory. Meanwhile, we're heading further to the binary star system 55 Cancri. It lies 41 light-years away from Earth and hosts an amazing planet, 55 Cancri e, also known as Janssen. This is a scorched super-Earth, 8 times the mass of our planet, and it orbits its star in just over 17 hours. Yep, the year on this planet is shorter than 1 day on Earth. Plus, it's 25 times closer to its star than Mercury is to our Sun. No wonder the planet's surface reaches blistering temperatures of 4,350 degrees Fahrenheit. That's hot enough to melt nearly any known metal. Back in 2010, a study found out that the host star of 55 Cancri e had an unusually high carbon-to-oxygen ratio. If this ratio was also true for the planet, it would mean that 55 Cancri e might have huge quantities of carbon. And the coolest thing? It would be in the form of diamonds. It'd make this space body a literal diamond planet. Sadly, some follow-up studies discovered that the carbon-to-oxygen ratio on the planet was less extreme than originally thought. It makes the idea of a diamond-encrusted world less feasible. On the bright side, planets don't always have to match the composition of their host stars exactly. If some other process topped up the carbon on 55 Cancri e, it could still be the most precious planet known in the universe. Definitely worth a visit. But let's leave the diamond planet behind and fly to Vega, which holds a special place as one of the brightest and most important stars in the sky. The brightest of other stars is measured against the brightness of Vega on a special magnitude scale, where Vega's magnitude is 0. A star with a magnitude of 1 is 2.5 times dimmer than Vega, and a star with a magnitude of -1 is 2.5 times brighter. Vega is also a pole star, although not at the moment. Right now, Earth's axis points toward Polaris, the North Star, but Earth's axial tilt draws a circle over 26,000 years, and Vega will again be the pole star in about 12,000 years. Just you wait. But the coolest thing about Vega, which sets it aside from other stars, is that it's not shaped like a perfect sphere. Unlike the Sun, which rotates slowly and is almost spherical, Vega spins very fast, completing one rotation in just 12.5 hours. And it causes it to bulge at the equator, taking on an egg-shaped appearance. And now, get ready for the most dangerous encounter of them all. But first, I must warn you. Even though space is unimaginably vast, it's populated extremely sparsely. The universe's average density is equivalent to 6 protons in 35 cubic feet. But some areas, known as voids or supervoids, contain even less matter. These regions are enormous and can span 30 to 300 million light-years, and there's almost nothing there. There are also places in the universe where time and space are distorted in ways that challenge our human comprehension, like binary black hole systems, where 2 massive black holes dance around each other before eventually merging. As they spiral closer, they release immense gravitational waves that ripple across space-time. The first detection of such waves was made by the Laser Interferometer Gravitational Wave Observatory in 2015, when it recorded the final collision of a black hole pair. In the final 20 milliseconds before the merger, the black holes released more gravitational energy than the total energy emitted by all the stars in the observable universe during the same period. But that's not all the universe has to offer. Once you start exploring, you can come across exoplanets like Corot 7b, where rock clouds form and send pebbles raining from the skies, or Kelt 9b, the hottest known planet with surface temperatures reaching 7,800 degrees Fahrenheit, or Tres 2b, the darkest planet ever discovered. It absorbs over 99% of the light it receives, making it blacker than coal. So, as you can see, in the vast, almost incomprehensible scale of the cosmos, mysterious, fast-moving objects, strange planets, and immense voids serve as a reminder of how much we have yet to learn about the universe.
Now imagine something so powerful that it could rip the atoms of your body apart in a fraction of a second. Ow! This something is soundlessly dashing through space, not extinct, not alive, stuck in between. If this terrifying monster were moving towards Earth, we'd be doomed. So, is it? Astronomers have found a fast and powerful space object zooming through our home Milky Way galaxy at over 110,000 miles per hour. That's faster than any rocket we've ever made. This bizarre space object got its name of a zombie star, all because it's the leftover part of a star that passed away a long time ago, but is still moving. This zombie star is a kind of an object called a magnetar, a super small, super heavy ball about the size of a city but heavier than the Sun. That makes it one of the densest objects in space. Only black holes are denser. Hey, let's not forget about me, huh? Magnetars also have an incredibly strong magnetic field. The one our zombie guy has is 100 trillion times stronger than Earth's. That's so strong that if the magnetar came close to Earth, it could wipe out every credit card on the planet just from its magnetism, and we couldn't shop anymore. Plus, if a person got too close to a magnetar, like 600 miles or so, it could pull their very atoms apart, and they couldn't shop anymore. Luckily, this magnetar is very far away and not coming near us. When it was first discovered, it was about 15,000 light-years away from Earth. That's a huge distance, so you don't get to worry about your atoms being disconnected yet. Astronomers first spotted the zombie magnetar in 2008. And since only about 30 magnetars are known in our galaxy, it was a lucky and rare find. Scientists use space telescopes like Hubble and Gaia to watch it over time. That's how they discovered it was moving much faster than they thought. Now, astronomers are trying to figure out how this zombie star got such a big kick. At first, they thought that, like most magnetars, this one was born when a giant star exploded in a supernova and the leftover core became a super-dense neutron star. According to their theory, it could have happened near something called supernova remnant HB9. That would make sense since most magnetars are created this way. But when they tracked its movement, they found that the zombie star was moving too fast and going in the wrong direction to have come from HB9. They traced its path thousands of years into the past and still couldn't find any exploding star or star cluster it could have come from. This means scientists now have one more mystery on their hands. Where did this zombie star come from, and how was it made? One explanation is that it came from a white dwarf, which is the leftover core of a smaller star like our Sun after it runs out of fuel. Now normally, when white dwarfs explode, they're destroyed completely. But in rare situations, instead of blowing apart, a white dwarf might collapse into itself and turn into a neutron star. This neutron star could then become a magnetar. This unusual way of forming a magnetar also gives clues about another mystery: fast radio bursts, or FRBs. These are very quick and powerful flashes of radio energy from deep space. Some FRBs come from galaxies that are so old there shouldn't be any exploding stars left. But if magnetars can be born from collapsing white dwarfs, that might explain how those FRBs are still happening. In any case, learning how magnetars form could help us explain many strange and powerful events we see across the universe. But so far, the investigation is still on, and no answers have been found yet. Zombie stars wandering across the universe isn't the only mystery we haven't solved yet. At one point, you might come across one of them while traveling through the cosmos. It looks like nothing. At a distance of 700 million light-years away from Earth, there's a hole, a blank void that has very few galaxies. This is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there thousands of times over. It's the mysterious Bode's void in the constellation of Bodes. Yeah, makes sense. You see, galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are huge, empty voids that hardly contain any galaxies. Such voids make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bode's void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, I wasn't around then, all the matter in the universe was packed together quite tightly. Astronomers even thought it was something like a uniform soup. But soon, random quantum fluctuations started disturbing this matter. Some areas became denser, and their gravitational pull became stronger. They began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. If you visited a star cluster called Palomar 5, you'd forget all about voids and supervoids and even zombie stars. Instead, you'd need to concentrate on surviving, since the region is hiding a swarm of over 100 black holes right in the middle. And those black holes aren't just sitting there, they're at work, shaping the cluster nonstop. Palomar 5 is a group of stars located about 80,000 light-years away from us. Normally, clusters like this are dense and tightly packed, with stars all bunched up together. But Palomar 5 is different. It's spread out and has a huge tail of stars stretching across 30,000 light-years. This beautiful tail is called a tidal stream. It's like the stars are spilling out of the cluster, creating a long river of light. Tidal streams like this are rare and hard to study. Globular clusters like this one are super old. Some are almost as old as the universe itself. But Palomar 5 also stands out because it's the only cluster we know about that still has a tidal stream attached to it. And the black holes inside the cluster might be to blame. They're pulling on the stars in the cluster, messing with their orbits, and slingshotting them right out of the cluster. Or would that be slingshooting? I don't know. Anyway, these stars are what make up the tidal stream. Over time, more and more stars get flung out. Palomar 5 has way more black holes than expected. About 20% of the cluster's mass is made up of black holes, over 100 of them, each about 20 times the mass of our Sun. Of course, Palomar 5 isn't going to last forever. In about 1 billion years, the cluster will completely fall apart. By then, all the stars will have been gone, leaving behind just the black holes. And these black holes will orbit the Milky Way, like a ghostly remnant of a cluster that used to be there. Even though this cluster is creepy enough, there's something even more eerie you can see in space: thick clouds of gas and dust called nebulae. One of the most unusual ones is probably NGC 2392, located 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and became popular because of its unusual appearance. It's basically a disk of material with a ring of comet-shaped objects. The tails of these objects stream away from the star at the center of the nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. The middle resembles a ball of twine, but in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Wow.
You're traveling through space, trying to get through an especially rough patch. You gotta dodge asteroids, space debris, wandering black holes. Now, it's not an episode of a sci-fi series, at least not completely. For the first time ever, astronomers have found a black hole that's completely alone, drifting through space with no stars or planets nearby. This black hole is about 5,000 light-years away from us in our own Milky Way galaxy. Do we need to look for a hero with superpowers to save Earth? First things first, a black hole is a place in space where gravity pulls so much that nothing, not even light, can get out of this region. The gravity is so strong there because a huge amount of matter is squeezed into a tiny space. Supermassive black holes, hundreds of thousands to billions of times the mass of our Sun, are often found at the centers of galaxies. Most of them stay put or move at a very, very slow pace. But the newly discovered black hole is much weirder than anything we've seen before. First of all, it tries to avoid commitment. It's lonely, with no companion star or home galaxy. An even stranger thing is that it's zooming through space at a speed of 31 miles per second. What might be the reason for this speedy cosmic journey? Let's look at the following imaginary scenario. One day, a really massive star exploded in a supernova. It was the very star that formed our black hole. The resulting blast gave the new black hole a massive kick and sent it flying through the galaxy, starting its unbelievable voyage. Now, it's only one of a few possible explanations, but it sounds quite plausible. I bet you can't help but think, what if this wandering black hole decides to visit our solar system? Are we doomed? Scientists tell you to relax and breathe out. This black hole is very far away, and your chances of ever encountering it are infinitesimal, if any. Plus, this black hole is totally quiet and dark at the moment. One day, it might wake up and start glowing. It'll happen if it begins to eat something. In the near future, powerful new telescopes may find many more wandering black holes like this one. Usually, black holes are super hard to find because they don't give off any light. You can only detect them when they're eating nearby matter. That makes them glow brightly. Or when they have a companion star. In this case, it moves in a strange way, which gives away the presence of a black hole. But this newly discovered black hole is lonely, totally by itself. There's no glowing, no companion star moving hectically. So, how did scientists spot our cosmic wanderer? They used something called gravitational microlensing. That's when the black hole's gravity bends and magnifies the light from a star located behind it, kind of like using a magnifying glass, hence the name. This method allowed scientists to detect the black hole even though it was completely dark. All in all, black holes are fascinating things, and some of them are truly unique, like these biggest black holes ever found. You see, almost every galaxy has a supermassive black hole at its center. They're huge, with masses millions to billions of times bigger than our Sun. One of those is called TUN 618. It's a really huge and powerful black hole that's part of something called a quasar, a super bright spot in space emitting incredible amounts of energy. TUN 618 is very, very far away, about 18.2 billion light-years from Earth. And it's 40 billion times heavier than our Sun. There are also black holes that feed on their own kind. Black holes are known for devouring anything that gets too close. And this anything can include not only stars and gas, but also other black holes. Scientists witnessed a ginormous black hole at the heart of one galaxy being swallowed by an even larger black hole in another galaxy. It was the first time we detected such an event. The discovery was made using NASA's Chandra X-ray Observatory. One black hole weighs about 30 million times the mass of the Sun, while the other has at least 1 million times the mass of the Sun. Then, there is a bullet-shooting black hole. Apparently, black holes don't just swallow matter, they can also shoot it out. For example, astronomers studied one relatively small black hole, which is about 28,000 light-years from Earth and weighs between 5 to 10 times the mass of the Sun. And they saw how this black hole pulled matter off a companion star and then blasted some of it out in the form of huge bullets of gas. These bullets are super fast. They move at nearly a quarter the speed of light. Some black holes spin incredibly fast, twisting space around them at extreme speeds. One example is a black hole located in the constellation Agila, about 35,000 light-years from Earth. This black hole spins at a staggering speed of more than 950 times per second. If you could place an object on the edge of this black hole's event horizon, it would spin around the black hole at 333 million miles per hour. That's nearly half the speed of light. The smallest black hole discovered so far has been nicknamed the Unicorn. Located 1,500 light-years away from Earth, it's around 3 times the mass of our Sun. This makes it very close to the smallest possible size for a stable black hole. While black holes themselves are far away and difficult to study directly, scientists find new clever ways to study their properties right here on Earth. They've been able to recreate certain features of black holes in the lab. For example, black holes have a gravitational pull so strong that nothing, including light, can escape once it crosses the event horizon. To understand this better, researchers have created an artificial event horizon using fiber optics. They've also been able to simulate Hawking radiation, the kind that likely escapes black holes, by setting up experiments in the lab. These lab-created mini black holes help scientists understand the mysterious properties of real black holes. There are several types of black holes, and each of them is born in its own unique way. Primordial black holes are believed to have formed right after the Big Bang, when the universe was very young. Stellar black holes form when a massive star collapses in on itself. This causes a supernova, where the outer layers of the star explode into space and the core turns into a black hole. As for supermassive black holes, they're thought to have formed alongside the galaxies they're in. The size of the black hole is usually related to the size and mass of the galaxy. Despite what many believe, black holes don't roam the universe randomly, looking to swallow planets. They obey gravity like anything else in space. So, for a black hole to affect Earth, it would have to be very close, much closer than any black hole is to us right now. Even if a black hole the same mass as the Sun replaced our Sun, Earth wouldn't fall into it. The black hole would still have the same gravity as the Sun, and Earth would continue orbiting it just like it orbits the Sun today. It would get much colder though, so we wouldn't survive such a replacement in any case. But don't worry, our Sun will never turn into a black hole. It doesn't have enough mass to do so. Instead, in about 5 billion years, when the Sun reaches the end of its life, it will become a red giant star. After using up its fuel, it will shed its outer layers, creating a glowing ring of gas called a planetary nebula. What's left will be a cooling white dwarf star.
When astronomers started a project that was organized to create a detailed 3D map of our galaxy, they didn't expect to find anything surprising. But that's exactly what happened. Earlier in that year, Harvard scientist Dr. Anna Bonacca noticed a weird disturbance in our galaxy's stellar streams. A stellar stream is a line of stars that are moving together through galaxies. The stellar stream we're talking about is called GD1, and it's stretched in an impressive line across our sky. This stream used to be a cohesive line, stretched by the gravity of our galaxy. One day, Dr. Bonacca noticed a gap in it, and this gap had a strange, ragged edge. In fact, it looked like something terrifyingly huge recently plunged through the stellar stream. The sheer force of this object's gravity was so great that it managed to drag stars in its wake. The most shocking thing was that the telescopes simply failed to find the source of the damage. But then, what could this unseen bullet be? One theory suggests that the intruder is a stray star. But, according to Dr. Bonacca, the hole is way bigger than any existing star. It'd have to be 1,000,000 times more massive than our Sun. Okay, so what if the hole in the Milky Way was torn by a supermassive black hole, like the one that dwells in the center of our galaxy? If these two black holes got too close, they wouldn't be able to escape each other's gravity. A collision might be inevitable. Then the stronger of the two holes would consume the weaker one, and one huge, super mighty black hole would appear. But people have yet to witness a collision of black holes. Plus, scientists can't predict the consequences of such a merge, even though they've simulated it on powerful computers. The only obvious fact is that it would produce incredible amounts of energy. Huge ripples would travel through the entire universe, bound to hit our planet eventually. Then again, two black holes in one galaxy might refuse to merge. Imagine this. A supermassive black hole hundreds of millions of times the mass of the Sun is spinning in the center of the Milky Way at a phenomenal speed. Another spinning black hole approaches ours. What do you think will happen? Right, one of the holes, most likely the intruder, will get kicked out and sent hurtling away like a frisbee flying through space. And who can guarantee that it wouldn't head toward the Earth? Luckily for us, there aren't any supermassive black holes in the vicinity, so this theory fails to explain the mysterious bullet hole phenomenon. Dr. Bonacca still doesn't rule out the possibility that the intruder is some kind of luminous, star-like object. After tearing a hole in the Milky Way, it could be hiding somewhere in the galaxy. But again, it seems highly unlikely because of the object's huge size. I mean, we're talking 30 to 65 light-years across. In any case, it's hard to predict where it would have ended up if it were a luminous object. The intruder could have been moving at an incredibly high speed and wouldn't have to be very massive to tear a hole in the stellar stream. Or it could have been moving more slowly, but be very heavy. But the astronomers don't know which option it was. That's why it's next to impossible to predict where it ended up.
Tiny critters to colossal creatures, all animals are trying to escape from a wall of fire moving in their direction. The temperature is rising, and everything around starts catching fire. Soon, lots of animals and plants on Earth will cease to exist. This is the aftermath of a giant asteroid crashing into our planet. But what if dinosaurs had had critical thinking skills? They could have guessed what was going to happen, because this asteroid was visible a year before the impact. 1 year before the impact. With no city lights, all bright spots in the sky are stars. Some of them are planets reflecting the light coming from the sun, like Mars. But one of these dots is the asteroid. Later, it's going to be known as Chicxulub Impactor. It got this name because of the region of modern-day Mexico where it fell. Anyway, at this point, the asteroid looks like a star. It has the same brightness as Neptune. You could even have photographed it with a high-quality camera. If only dinosaurs had thumbs. The impactor is now passing through Jupiter's orbit. From this distance, Earth looks like a pale blue dot. 1 month before impact. The asteroid has become much brighter. It's now the most brilliant spot in the night sky after the Moon. The asteroid crosses the orbit of Mars. Its tail, consisting of dust and gas, is getting longer and longer. It's now as long as 2 times the distance from Earth to the Moon. 1 week before the impact. The intruder's tail is now 5 times the distance from the Earth to the Moon, but the dinosaurs can't appreciate its beauty. To them, it's just another bright dot in the night sky. If this asteroid were flying toward Earth right now, scientists could pinpoint the exact location of its impact within a mile. Then we would evacuate people from the impact area and avoid a major catastrophe. 1 day before the impact. The Chicxulub Impactor now holds first place among the brightest objects in the sky. The light surrounding it, called the halo, seems even bigger than the Moon itself. The asteroid is now passing through the Moon's orbit. It looks like a bright spot that leaves an ashy trail behind it. 1 hour before the impact. The light from the Chicxulub Impactor is brighter than the full Moon, and its movement can be seen with the unaided eye. Nights on Earth aren't dark anymore. Only now, dinosaurs begin to feel anxious. All animals on Earth start to seek shelter. 10 minutes before the impact. The asteroid is now passing through Earth's orbit. Thousands of small fragments from its tail begin to fall on the planet. It looks like a meteor shower. So far, these fragments are too small. They all burn up in the atmosphere before reaching the surface of the planet. The asteroid is approaching South America. If someone was looking at it from Europe, it looked like a sunset. The bright dot of the Chicxulub Impactor is falling behind the horizon. 2 minutes before the impact. Dinosaurs can now easily see the asteroid's shape. If they knew how to do it, they could even estimate its size. It's a bit more than 6 miles across, which means it's almost the size of Manhattan Island, and the giant's weight is 15 plus 15 zeros pounds. It's flying toward the Yucatan Peninsula at a mind-boggling 7.5 miles per second. At that speed, you could get from New York to Los Angeles in around 10 minutes, but you'd kind of burn up on the way. 10 seconds before the impact. The Chicxulub Impactor is now approaching the ground. A few more feet and bam! The night sky suddenly turns white. The flash is so bright that the sun isn't visible at this point. The asteroid's entry causes a powerful blast that can be heard on the other side of the world. The huge asteroid begins to burn because of friction with the air. It heats up and splits into many pieces. These pieces shower on Earth. After a few seconds, the largest part of the meteorite hits the ground. Its mass and speed provide the Chicxulub impactor with an enormous amount of energy. In the next moment, a super powerful explosion shakes the ground. The blast wave from the meteorite begins to spread out from the impact site. It rips out huge chunks of soil and trees and then pushes them to the ground like dominoes. The temperature of the blast wave is so high that everything around the impact site catches fire. The energy released during the collision also penetrates deep into the planet. This causes the strongest earthquakes in our planet's history. They in turn generate tsunami waves as high as the Empire State Building. 5 minutes after the impact, the meteorite leaves behind a huge crater. It's as wide as Lake Huron and deep enough to fit inside 2.5 Mount Everests. Dinosaurs are running around in panic. They try to evacuate toward North America, but most of them don't make it through unfamiliar swampy territories. Another danger is the ongoing meteor shower. Hundreds of tons of ash and debris rise into the air. Heated up by high temperatures, they fall to Earth in the form of liquid lava. Ash and smoke fill the atmosphere and block the sun's rays. Earth plunges into darkness. For several more weeks, our planet will be totally dark. Acid rains will fall on its surface non-stop. There was a lot of sulfur in underground deposits on the Yucatan Peninsula. The energy of the explosion evaporated all this sulfur. Now it's cooling in the air, gathering in clouds, and dripping to the ground. Most animals survive the impact, but the mass extinction continues for many more months. The collision has plunged Earth into darkness, and this has wiped out most of the plants that fed on sunlight. The plant-eating dinosaurs have lost their main food source and begin to disappear. But plant-eating dinosaurs are the main diet of meat-eaters, and now dinosaurs like T-Rex have nothing to eat. Soon they go extinct too. In other words, it wasn't a meteorite that wiped out dinosaurs, but hunger and climate change. Meteorites of this size fall once every 100 million years. It means that such an event might happen again. Will humans manage to survive this disaster? These days, we can look out far into space, and the appearance of an asteroid the size of the Chicxulub impactor won't be a surprise to astronomers. In general, asteroids that are more than 460 feet across are considered potentially dangerous. Anyway, if we know about the approaching space body, we'll be able to build shelters filled with food and water supplies. Once the asteroid is close enough, we can wait for the impact and its consequences inside. But when people come back to the surface, they'll see cities and towns torn down. Our planet will look like a lifeless desert. That's why we need another alternative, which is to prevent the impact. Here, we have many options depending on the size and material of the asteroid. According to NASA, the most effective way is a kinetic ramp. We'll need to send a fairly large and heavy object, such as a spaceship, into space. When it approaches the asteroid, scientists will choose the perfect trajectory, and the ship will crash into the space body. A powerful collision will change the asteroid's course, making it fly past Earth. The further this space body is from our planet, the easier it'll be to send it away. Another option is a controlled explosion on the surface of the asteroid. Newton's first law of motion will help us here. It says if a body is moving at a constant speed in a straight line, it will keep moving that way unless it is acted upon by a force. So, if we make a big enough explosion, or force, the asteroid will shift its trajectory. How much it moves depends on the amount of force applied to it. We can also blast the asteroid right from inside. In this case, there will be no need to change its trajectory. Instead, we'll try to turn one huge hunk of rock into a bunch of smaller fragments. They will burn up in the atmosphere and do no harm to our planet. Another way is a gravity tug. Every heavy object has its own gravitational force and gravitational field. Our goal will be to send a spacecraft to the asteroid and make it fly close to the intruder. The asteroid will attract the spaceship, but its engines will resist. As a result, the ship will slowly but surely pull the asteroid toward itself. This method will take much longer, but gradually, the trajectory of the asteroid will change and it won't crash into Earth. Hopefully. We can also use solar power. We can build a spaceship with a system of giant magnifying lenses. Then we'll send that station closer to the Sun. When we spot an asteroid, we'll point the lens in its direction and focus the beam on the space body. The heat from the Sun will cause the asteroid's material to evaporate. Eventually, this will make the intruder change its trajectory.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the Sun. Bernardinelli-Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space. Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the Sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernardinelli-Bernstein is too far away from the Sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernardinelli-Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it'd produce a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernardinelli-Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and trigger huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. The most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernardinelli-Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the Sun. That's 20 times the distance from Earth to the Sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernardinelli-Bernstein will approach the Sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the Sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system, but that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the Sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile wide block of rock showered our planet with small meteors. Since the asteroid often passes by the Sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bam! Or we could build a space station, like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the Sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the Sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, space bodies absorb most of the Sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.
Scientists have thought for a long time that really huge black holes, those called supermassive black holes, sit in the middle of all big galaxies. But for some reason, try as they might, they couldn't find one in a galaxy called the Southern Pinwheel Galaxy, aka Messier 83, or M83, a spiral-shaped galaxy about 15 million light-years away from us. Still, researchers were sure it would be there. That was super confusing. And now, the super-powerful James Webb Space Telescope might have found a clue that there really is a supermassive black hole hiding in the middle of M83. Supermassive black holes eat up huge amounts of gas and dust, which makes them glow super bright. M83 didn't seem to shine, but could this glow be hidden by thick clouds of dust? Indeed, James Webb's amazing cameras have spotted clumps of special ionized gas that show up when a black hole is doing its thing, gobbling matter. So basically, the black hole could be playing hide and seek with us, and JWST might have just helped us figure out this long-standing mystery. So what exactly did scientists see? It was a glowing light coming from neon gas that needs a huge amount of energy, much more than what normal stars can make. This glow is a strong clue of a hidden active galactic nucleus. Even powerful star explosions, called supernovas, don't give off enough energy to make this kind of light. So, a supermassive black hole seems like the most likely reason. On the other hand, it's not the only possible reason. The glow might also come from shockwaves moving through the gas between stars, called the interstellar medium. To figure it out, scientists are going to take an even closer look using other powerful space tools like the Hubble Space Telescope, ALMA, and the Very Large Telescope. At the same time, this discovery shows how amazing the James Webb Space Telescope is. Apparently, it can find things in space that were safely hidden from our eyes before. Another example is an impossible black hole it helped to detect. On second thought, this discovery might not be as astonishing as it seemed at first. Let's figure out this mystery together. The thing is, astronomers thought they had found a super hungry black hole that was eating stuff 40 times faster than it should. And that was something that didn't make sense with the existing laws of physics. That black hole, called LID 568, was spotted with the help of the James Webb Space Telescope. It was from the early days of the universe, having formed just 1.5 billion years after the Big Bang. So, at first, it looked like the ravenous black hole was eating way too much and way too fast. That would have made it grow really big really quickly, which was surprising for such an early time in the universe. But now, after looking again with the Webb telescope, scientists realized they had been wrong all this time. The black hole hasn't been breaking the rules at all. What actually happened was that thick dust got in the way and made it look like it was eating more than it really was. Here's how black holes normally work. When stuff falls into them, it gets super hot and shines brightly. There's a rule called the Eddington limit, which tells us that the most a black hole can eat is based on how big it is. If a black hole tries to eat more, the light it gives off pushes the stuff away, so it can't eat anymore. Some black holes can eat a little more than this rule says. This is called super Eddington accretion, but not as much as 40 times. And the first guess said that LID 568 was doing just that, breaking this limit in a big way. And then, the new study, published in April 2025, showed that the black hole was actually eating at a normal rate. The mistake came from not seeing clearly because of all the dust in space. It blocks and scatters light, making it harder for us to see the black hole clearly. So, in the end, our hungry friend turned out to be not so hungry and pretty normal. Kinda disappointing, right? Scientists say that if a black hole is hidden by dust, like LID 568, you have to fix the light measurements for the dust to get the right size for the black hole. If you don't do that, you might get the wrong number for how big the black hole is, which also messes up the calculation for the Eddington limit. In their study, the team measured the black hole size using infrared light. This light is not blocked by dust as much as regular light, which is what scientists usually use. Thanks to this, they found out that the black hole was almost 1 billion times bigger than the Sun, and about 40 times bigger than the old guess. With this new, bigger size, they could fix the calculation for the Eddington limit, which made it clear that the black hole wasn't as hungry and bizarre as they thought. So, its feeding habits don't mean it's a super huge black hole growing really fast. Scientists have known that dust can mess up measurements of black holes, but they haven't always been good at fixing it when studying galaxies far away. This means that other black holes might have also been measured incorrectly, and people might have misunderstood them. The team's new way of measuring could help scientists learn more about these black holes that are hidden by dust in galaxies, especially the little red dots galaxies discovered with the James Webb Space Telescope. When scientists look at the first pictures of those faraway parts of the universe, they found something totally new: a bunch of tiny, super red galaxies. They named them the little red dots. There are hundreds of them. These dots only show up during a short time in the universe's history, when the universe was about 1 billion years old. And these little red dots are super confusing. They kind of look like two totally different things: really heavy galaxies packed with stars, or modestly sized galaxies with a supermassive black hole in the middle. But one thing is clear: the typical red dot galaxy is tiny, only about 2% the size of our home Milky Way galaxy, and some are even smaller. So, what makes them shine? There are two main ideas. One of them claims that each little red dot is filled with a crazy number of stars, up to 100 billion, which is about the same number of stars as the Milky Way, even though a red dot is way smaller. Imagine standing in a huge, quiet room. That's like space near our solar system. Now imagine that same room completely jam-packed with the whole population of a very large country. Super crowded. That's what the inside of a little red dot might be like. It could be one of the most crowded places in the universe. Scientists aren't even sure galaxies this packed can really exist. Another idea is that these red dots are small galaxies with a giant black hole in the center. Scientists can spot signs of black holes by looking at how gas swirls around them. It gives off a special kind of light. And in many little red dots, they've seen those signs. Now, here's the strange part. The black holes seem way too big for such tiny galaxies. Usually, a black hole is only a tiny part of a galaxy's weight, about 0.1%. But in some of these dots, the black hole might be almost as heavy as the whole galaxy. That's really unusual, so scientists call those monsters overmassive black holes. And there's one more mystery. Normal black holes give off X-rays, and these ones don't. Even when scientists use special telescopes to look for X-rays, they couldn't find any. It's like these black holes are playing hide and seek, and we don't have the necessary means to find them yet.